Alright, we are starting Chapter 7, Section 1, Angles of Polygons. We covered polygons at the beginning of the school year, so just some refresher that we should know about polygons. Looking at this, we know that polygons are shapes with 3 or more sides, and they're closed shapes, so we should definitely know that already. Looking at this, it says each segment that forms a polygon is a side of the polygon. So they're sides of polygons. The common endpoint of two sides is the vertex, so we should know that. An endpoint is where two sides meet and that make a point a vertex. So that's my vertex, which is right here. It's highlighted in blue for us. A segment that connects any two non-consecutive verticals is a diagonal. So the diagonal line has to do with this. Okay, non-consecutive. We should know what consecutive means. Alright, you will have to know the name of polygons. You can name the polygons by the sides. You can name a polygon by the number of its sides. The table shows the names of the common polygons. So these are some polygons that you should know. We already know 3 sides is a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. So think of the government building, the Pentagon. It has 5 sides. Hexagon is 6. So you should know how to spell 6. And it kind of has the X there for 6. 7 is heptagon. 8, think of an octopus, octagon. 9, nonagon. 10, decagon. 12, dodecagon. And anything larger than 12 is n-gon. So for example, if I were to say, I'll write it on here. If I were to say 14, that would be a 14-gon. And that's all you have to write it, just like that. Finding the sum of the interior angles. So to find the sum of the interior angles, what you want to do is draw diagonals to make triangles. So as you can see in these images, we should know the interior measurement of a triangle already. We already know that this is 180 degrees. Now, if I want to find the measure of interior angles of polygons with more than 3 sides, you have to draw the triangles on the inside. So create a set of triangles. The sum of the angle measure of all the triangles equals the sum of the angle measure of the polygon. So what does that mean? Looking at the quadrilateral that's given right here, if I were to draw my diagonal line right here, okay, I just split it into 2 triangles. So to find the measure of the interior angle of my quadrilateral, I have 180 and 180, which gives me a total of 360 degrees. So the interior measure of my quadrilateral is 360 degrees. So looking at my pentagon, I'm starting at a vertex and again drawing triangles to make them triangles on the inside. I drew 2 diagonals, which makes 3 triangles. So again, I have 180, 180, 180. This is going to give me a total of 540 degrees. So any pentagon is going to give me, the interior measure of any pentagon is going to be 540 degrees. So by knowing that, looking at my hexagon, drawing my triangles, I have 3 diagonals. Three diagonals, which gives me 4 triangles. So again, same thing we did before, 180, 180, 180, 180. Now I'm technically multiplying it times 4, and that's going to give me a total of 720 degrees. Now that's the interior angle measure. So we've worked with triangles already to find missing angles. Now we can work with other polygons. So there is a formula for this. So even though we drew our triangles, we added 180 together, there is a specific formula for this. So for your test coming up or quiz coming up, it's really good that you try and memorize these measures so you won't really have to do the math every single time. But super important that you guys remember the formula, because on your homework you may get a shape with 15 sides. I have a 15 gone. So how many sides? 15. Number of triangles. I'm able to make 15 minus 2. That's how you're getting the number of triangles. So again, triangles have one triangle. So right now I'm just looking at this and clarifying why I'm subtracting by 2. Quadrilateral, 4 sides. I can make 2 triangles. So this is going back to the previous slide on showing you how many triangles you can make. So that's where you're getting your minus 2 from. So solving this, I have 15 minus 2, which is going to give me 13, and I'm going to then multiply 13 by 180, and that's going to give me 2,340 degrees, and that's again my interior measure. Please, please, please make sure you memorize this formula. Super important that you memorize this formula because it will not be given to you. Memorize it, write it, please do not forget it. Alright, Theorem 7.1 and Corollary. Polygon interior angles theorem. So we just covered that. That's the formula for my interior angles. Just writing it out. N-gon, okay, is the number of sides minus 2 times 180. Okay, something you have to know. Corollary of Theory 7.1, Polygon interior angles theorem. The sum of the measure of the interior angles of a quadrilateral is 360. So quadrilateral have 4 sides, and that's 360 degrees. Please make sure you remember the formula. Super important. Always write it down so you guys have it and you memorize it, because again, it's not going to be given to you. All right, equilateral, equiangular. We should know the difference already. Equilateral has the word lateral, which means lines, which has to do with my sides. Equiangular has to do with angles, and we should know what angles are by now. If it's a regular polygon, a regular quadrilateral, that means all sides and angles are congruent. Okay, that means it's both equilateral and equiangular. Please make sure you remember that. It's only a regular polygon, regular quadrilateral, if all the sides and the angles are congruent. Congruent, if you forgot, means equal. And we'll go ahead and write it. Okay, again, and that makes it both equilateral and equiangular. Alright, so looking at this example, classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So looking at A, are all my angles the same? Yes, they all have one congruent mark. So looking at my angles, they're all right here. And then are all my sides the same? Yes, because they're all represented with one congruency mark. So this is considered, excuse me, a regular a regular, what kind of shape is this? How many sides? 1, 2, 3, 4, 5, 6. This is a regular hexagon. How do I know that? All sides are congruent and all angles are congruent. All right, looking at B, again, is it equiangular, equilateral, or irregular? Okay, so looking at my angles, these angles are congruent. These angles are congruent, so it's not equiangular. And let's see if it's equilateral. This one has 2 symbols, so that's congruent. And this one has 1, and those are congruent. So looking at the shape, this is a quadrilateral. And is it equiangular, equilateral, or regular? This is none, because it doesn't have the same measures for the angles, and it doesn't have the same sides. All right, looking at C, are all my angles and sides congruent? First, I want to figure out, what would I name this? So looking at this, what would this be called? Let's figure out how many sides there are. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, I know this is going to be called a dodecagon. And then let me go ahead and look at my sides. So are my sides congruent? So highlighting them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All my sides are congruent because they're all represented using my congruency marks. So I'm going to say all sides are congruent, which makes it equiangular. I'm sorry, equilateral. However, I know all your angles look like they're 90 degrees, but I'm going to highlight them again so you could see it. These angles are 90 degrees, which are my interior angles, but these angles right here are not 90 degrees, so it's not equiangular. So this is just a decagon that is equilateral, not equiangular. So we have to know which ones are which when we're finding them. All right, now we have another theorem, the polygon exterior angle theorem. It says the sum of the measure of an exterior angle of a convex polygon, one angle at each vertex is 360. What this means is any polygon you have, the sum of the exterior angles is always going to be 360. So it doesn't matter what kind of polygon you have. If you have a hexagon, your sum of the exterior angles is going to be 360. If you have a 50gon, the sum of the exterior angle measures is still going to be 360. So for this, any polygon, it's always 360, no matter what kind of polygon it is. So just giving you an example, if I had a triangle, so here's a triangle, and I decide to extend my lines. Okay, remember, now this is a regular triangle. This is a regular triangle, and going back, regular triangle means all my sides are going to be congruent, are equiangular. All my sides are equilateral, and all my angles are equiangular. And we already know in an equiangular triangle, all of my angles are 60 degrees. So looking at this, my sides that are extended form a linear pair. Okay, so linear pair means it makes a straight line. So when I'm looking at this, if I wanted to figure out, again, my exterior angle measures, and I wanted to continue these over, all you have to do is do 180 minus 360. I'm sorry, 180 minus 60, which is going to give me 120 left over. So all of these exterior angles are going to be 120. Okay, and looking at it for my regular polygon, okay, my regular polygon, which is my triangle, if I add all 120, 120, 120, all of my exterior angles, that's going to give me a total of 360 degrees. So it doesn't matter what kind of polygon you have, all the exterior angles added together equal 360 degrees. So if I were to ask you on a test or quiz, what's the measure of the exterior angles of any shape, make sure you write 360 degrees. Alright, the measure of each interior angle in a regular polygon. This is for you to find the measure of each interior angle for a regular polygon. Remember, regular polygon is equiangular and equilateral. So it's going to be the same measure for every single angle, interior angle. So when you're looking at this, just giving an example, we're going to use what we did before, our regular triangle. So our formula is n minus 2 times 180 divided by n, and my regular triangle has 3 sides. So I need to solve for each interior angle of a regular triangle. We're just using a triangle, but this works for any regular polygon. So plugging it in, I'm going to have 3 minus 2 times 180 divided by 3. That's going to give me 1 times 180 divided by 3. I'm going to get 180 divided by 3, and that's going to give me 60 degrees. So that means for my regular triangle, each interior angle is going to be 60 degrees. So you guys have to be able to know how to work backwards. If I gave you the total interior angle measure for a regular polygon, any regular polygon, you'd have to be able to work backwards to tell me the interior angles. So that's a way that you're going to be using this formula. So please make sure you guys remember this formula, and this is for a regular, any regular polygon only. Okay, it has to be a regular polygon, and you're finding each interior angle. So every interior angle of a regular polygon. Alright, so find the sum of A interior and B exterior angles. So they're giving us numbers already. They're giving me a heptagon and a 17gon. So we have to know what heptagon is. So going back to your chart, if you have to, heptagon means there are 7 sides. So to figure out A, which is my interior angle, I have to know my formula. So A, formula for interior angles, I'm just going to go ahead and write it. It's the number of sides minus 2 times 180. So let's go ahead and solve for heptagon for part A. So looking at part A, I have 7 sides. So I'm going to plug in 7. So where am I getting my 7 from? Because I already know a heptagon has 7 sides. I'm going to take that 7 minus 2 times 180. So I'm going to go ahead and subtract. It's going to give me 5 times 180. And then if I multiply correctly, that's going to give me 900. So the interior angle is going to be 900 for A. And the exterior angle, Remember, going back to the previous slide, your exterior angle measures are always going to be 360 degrees. Always. So I don't even have to solve anything for that one. I'm just going to get 360. So going to the next question, I have a 17 gone. That means the number of sides is going to be 17. And again, I'm going to go ahead and solve it. I'm going to use the formula. I have 17 minus 2 times 180. I'm going to get 15 times 180. If I multiply correctly, 2,700 degrees is the measure of my interior angle. So that's the measure of all the angles inside if I added them together. And then B, my exterior angles again is going to be 360 degrees. Okay, any polygon, the exterior measures are 360 degrees. Please don't forget that. All right, looking at example number 3, it says find the number of sides of a convex polygon with the sum of the measure of its interior angles equal to 900. So they're telling me that it equals 900, so I need to work backwards. So I'm going to have my formula, that's my interior angles. I have my formula, which is my number of sides minus 2 times 180 equals 900. And now I have to work backwards and solve for n. So looking at this, I'm going to go ahead and solve what's on the left side first. I have 180n minus 360 equals 900. So I did this first. Now I can go ahead and add 360 to both sides. These are going to cancel out. I'm going to get 180n equals 1,260. Next, I'm going to go ahead and divide both sides by 180. These are going to cancel out. N is going to equal, if you divide correctly, 7 sides. So from what we know, a shape with 7 sides. So this is number of sides. We want to know the polygon. The polygon is a heptagon. A heptagon has 7 sides. So that is definitely something that, again, you have to memorize the name of your shapes. It will not be given to you. You have to remember the formula and the names. So for this question, I just worked backwards. And then I solved for how many sides, and then they gave me my answer. Another way to solve this is if you have n minus 2 times 180 equals 900. You can get rid of your 180 by dividing both sides by 180. And that gets rid of your 180. So then you have n minus 2 equals, if you divide correctly, you're going to get 5. And then solving for n like normal. So add 2. And then you're going to get n equals 7. So you're still getting the same answer as before. You're just solving it a different way. All right, looking at the last example, it says find the measure of each interior angle and each exterior angle of the given polygon. Looking at this is all regular polygons. So that means all my angles and all my sides are going to be congruent. So 2 things I'm going to use. For my interior angles, I'm going to use my interior angle formula, which is n minus 2 times 180 divided by n, because this is for a regular polygon. These are all regular polygons. And then for my exterior angles, I'm going to use 360 divided by n. Why am I dividing it by n? Because again, all the angles are going to be congruent. So I want to know the total for each angle. So a regular quadrilateral. This one should be pretty easy. If it's a quadrilateral, it has 4 sides, so we should already have an idea that this is 90 degrees. But if you didn't know, we should know that a quadrilateral has a total of 4 sides. So setting it up in my equation, I have 4 minus 2 times 180 divided by 4. That's going to give me 2 times 180 divided by 4. And then I'm going to get 360 divided by 4, which gives me that 90 degrees. So that's for my interior. Then I'm going to have my exterior. I have 360 divided by 4, and that one's pretty easy again, like I did before. That's 90 degrees, and this is for my exterior. So just drawing it out for you, here's my quadrilateral. That's telling me that all my interior angle measures are going to be 90 degrees. So I will go ahead and highlight what the interior angles are right here. And then if I were to continue drawing these lines, that's telling me all of my exterior angle measures are also 90 degrees. So that's on the outside. Okay, those are all 90 degrees. So that's basically the thought behind it. So regular octagon. Octagon has 8 sides. Think of an octopus. So now I'm going to go ahead and do the same thing and plug it in. I have 8 minus 2 times 180 over 8. Solve it out. I'm going to get 6 times 180 over 8. Using what we know, we can cross simplify these. I'm going to change this to a 3 and a 4. I like to work with smaller numbers, so you don't have to do that. You could just multiply across, but I want smaller numbers, so I'm going to do it that way. I have 540 over 4. And then if I solved it correctly, that's going to give me 135 degrees. And this is for, again, my interior angles. Doing the same thing for my exterior, I'm always going to take 360 degrees, dividing it by 8, and that's going to give me 45 degrees for my exterior. And then the last one, 15 gone, so they're telling me the number of sides is 15. Plugging it in, 15 minus 2 times 180 divided by 15. I'm going to do 13 times 180 over 15. I can cross simplify my 180 and my 15. That's going to give me 12 and 1. So again, smaller numbers, I'm able to work with it a little better. And just multiplying straight across, I'm going to get 156 degrees. And again, that's for my interior. And then now for my exterior, same thing we did before, because it's a regular polygon, divide by 15. And that's going to give me a total of 24 degrees for my exterior. Okay.